Welcome everyone to our plane measuration series, the SSE aspect of it. Today we are dealing with perimeter, an area of segment of a cycle. First, we start with perimeter of segment of a cycle. We have a basic diagram shown on the screen. From the diagram, the perimeter of a segment is equal to length of arc ACB plus length of chord AB. Bearing in mind that perimeter is distance around a given shape. And the shape here is ACB. And that will give us theta over 360 2 pi r plus 2r sine theta divided by 2. Next, we take some example. 2008/37. XY is a chord of cycle center O and radius 7 cm. The chord SY is 8 cm long, subtends an angle of 120 degrees at the center of the cycle. Calculate the perimeter of the minor segment, taking pi to be equals to 22/7. The options are given. Solution. The sketch of the given data is as shown on the screen. Next, we give perimeter of a segment is equals to, quoting the formula, length of arc XY plus length of chord XY here in this diagram. Of course, the minor segment theta is 120 degree. So we go direct. Substituting for our given value, we have equals to theta over 360, 2 pi r plus 8. And we're substituting for the unknowns here. We have 120 over 360 times 2 times 22/7 times 7 plus 8, which is equals to 14.667 plus 8. And that will give us 22.67 cm. Another example, 2014/43 NECO. Calculate the perimeter of a minor segment of a cycle of radius 40 cm, subtending an angle of 120 degrees at the center. Take pi equals to 22/7. The options are given. Solution. Perimeter of a segment of a cycle is equals to length of arc plus length of chord. And that is the same as theta over 360 2 pi r plus 2r sine theta over 2. Substituting for the given values, we have equals to 120 over 360 times 2 times 22/7 times 14 plus 2 times 14 times sine of 120 over 2. And that will give us 29.333 plus 24.249. That's equals to 53.582, which is approximately equals to 53.58 cm. Next, we treat area of segment of a cycle. Area of segment of a cycle with diagram given above is equals to area of sector minus area of triangle, which is equals to theta over 360 times pi r square minus half r square sine theta. You can simplify it further by factoring out r square over 2 into bracket open pi theta divided by 180 minus sine theta, bracket close. Let's take some example. 2005/16 NECO. The figure above shows a sector of a cycle radius 12 meter, which subtends angle 135 degrees at the center O. Calculate the area of the shaded segment. Solution. Area of segment is equals to area of sector minus area of triangle, which is equals to theta over 360 times pi r square minus half of r square sine theta. Substituting for our given values, we have 135 over 360 times pi times 12 square minus half times 12 square times sine 135. Next, we note since we are dealing with an objective question, you look at the way the values are given, the options are given. We know we are dealing with trig ratios here. So we convert our 135 degree as sine 180 minus 135, which is the same thing as sine 45 degree. So we can get our answer without resorting to a four-figure table. And that gives us 135 over 360 times pi times 12 times 12 minus 1/2 times 12 times 12 times sine 45 degree. I will know from our trig ratios, sine 45 degree is the same thing as 1/√2. So we have 54 pi minus 6 times 12 times 1/√2. Rationalizing 1 over root 2, it will be equals to 54 pi minus 6 times 12 times root 2 over 2. And that is the same as bracket open 54 pi minus 36 root 2 bracket close m squared. Another example, 2005 3A NECO. A segment of a cycle of diameter 24 cm, subtend angle of 90 degrees at the center. Calculate the area of the segment to the nearest cm square. Take pi to be equals to 22 over 7. Solution. Area of segment is equals to area of sector minus area of triangle. And that is the same as theta over 360 times 2 times pi r square minus half of r square sine theta. Here, r is diameter divided by 2, and that is 24 divided by 2, which is 12 cm. Substituting, we have equals to 90 over 360 times 22 over 7 times 12 square minus 1 over 2 times 12 square times sine 90. The result is 113.14 minus 72. That will give us 41.14 cm squared. This is approximately equals to 41 cm squared to the nearest centimeter square. Another example, 2009/39 NECO December. A diagram is shown on the screen. We are asked to find the area of the shaded portion in the diagram above. If O is the center of the cycle, bracket open correct to 1 decimal place, the options are given. Solution. Area of segment is equals to area of sector minus area of triangle, which is equals to theta over 360 times pi r square minus half of r square sine theta. Substituting for the given value, we have 90 over 360 times 22 over 7 times 20 square times 20 square minus sine 90. Our 90 degree is implied from the diagram, and the result is 314.29 minus 200. And that will give us 114.29 cm squared, which is approximately 114.3 cm squared to 1 decimal place. We've come to the end of under this subtopic. Next, we'll have some exercises at page 358 of the Hidden Facts in USSC Mathematics. Please try your hands on the exercises. The answers are given at the answer section of the book. The hard copy are available in bookshop. If you're interested in the soft copy, you visit our website. The address is displayed at the bottom of the screen. Thank you.